for each identity below, they want us to list or determine the non-permissible values, and they want us to prove the identity. We're going to do it in the opposite order. We're going to prove the identity first, and through the proof, it's going to be easier to figure out the non-permissible values, because non-permissible values, okay, what are we not allowed to do? We've learned we can't square root negative numbers, and we can't divide by 0. Well, these ones have no square roots. So the only thing we're going to have to worry about is dividing by 0. And it's going to be easier once we see the proof. So we'll start with part A. Right? For a proof, we rewrite the question, we draw the line, and we look at the question to see if there's any strategies we'd like to use. If we're unsure of any strategy, we go to our basic one, change things to sine and cos, and get a single fraction, see how it goes. So cotangent, I could change that to cos theta over sine theta. Here's my main fraction line. Cosecant is 1 over sine theta. The right side is already cos. So here we have a fraction divided by a fraction. Put the bottom fraction and multiply. We're multiplying, these factors are identical, so they would simplify. And we're just left with cos theta. So our proof is done. Again, the main strategy worked beautifully. Change things to sine and cos, get a single fraction, simplified really nicely. Now, as far as non-permissible values, I'm going to take out my highlighter, and I'm going to divide everywhere in this question where we are dividing by something. Initially, we're dividing by cosecant, okay? Now, if you had to do a reciprocal function, to solve where that one has non-permissible values, you'd have to change to sine anyways. So it's going to be enough, if you've changed things to sine and cos, it's going to be enough just to check where you're dividing by sines and cos to figure out, in this case, for our non-permissible value, wow, our non-permissible values, can you see that if you're dividing by sine of theta, that sine of theta can't equal 0? And you're allowed your unit circle in this unit. Sine is your y-coordinate. So we look, where's our y-coordinate equal to 0? That's at 0, and pi, and 2 pi, and so on, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, and continuing that way. Or maybe remember that from chapter 6, all the zeros of sine are k times pi, where k is an integer. So it's a bit of a general solution kind of question when you're solving for non-permissible values. You're writing the general solution where sine of theta can't equal 0 for your non-permissible values. Same thing for part B. We'll prove first. We'll use the most common strategy, so we'll change the secant to 1 over cos. We have fractions inside of fractions. So when you have fractions inside of fractions, we need to get a single fraction in our numerator, a single fraction in our denominator. Our numerator could be written as a single fraction if you wrote it over 1. Our denominator, we would need to multiply this one by cos theta and cos theta. To get a single fraction on the bottom. And then if you have a single fraction on the top and a single fraction on the bottom, your rules for dividing fractions are to multiply by the reciprocal. Oh, look at this. I've got it written out already. So nice. So we flip the bottom fraction, and then the 1 plus cos theta would get grouped together, and it's identical to the 1 plus cos theta on the bottom. They would simplify, and we would just get cos theta. So our proof is done. As far as non-permissible values go, we need to check our entire proof of all the places we're dividing. I'm going to take out my highlighter. Dividing by cos here, and dividing by cos here, dividing by cos there. Don't have to highlight the one. Oh, but here I'm dividing by cos theta plus 1. So I need to highlight that one as well. So for our non-permissible values, cos theta can equal 0. When does that happen on your unit circle? It's your x coordinate, right? At pi over 2 and 3 pi over 2. So what you could do for your non-permissible values here is write the general solution. That's the general solution for cos theta equals 0, pi over 2 and 3 pi over 2. Or, if you remember from chapter 6, when we wrote this out, odd numbers times pi over 2 where k was an integer, you could write that. Question?
Don't we also have to include 1 plus 1 over?
We'll do that when we get to this one. Okay? Yes. So this is one non-permissible value. And the other one that we highlighted was that cos theta plus 1. That one also can't equal 0. So that would be when cos theta equals -1. When is your x coordinate -1? Write the general solution for that one. So if we highlight all the places we're dividing with cos theta, okay, this cos theta plus 1 will include this. So the 1 plus secant theta got solved in the same way with the cos theta plus 1 equals 0. If you have reciprocal functions, if you change them to sine and cos and check through your entire proof of all the places that they appear, you will be able to get all of your non-permissible values. All right, questions for this one are 4, 8 and 9, but the proof part's only and 11.